Right. Good evening.
Good evening, sir.
Right. Any questions related to the last session?
No questions, sir. Everything was
Right.
clear.
Okay. Then let's discuss about the worksheet uh, quickly. So the first question below is a sample data set for the heights and weights of 10 men. Then heights given in inches and weights given in uh, so then here you can see that so the questions, then first one, draw a scatter plot for the above data, use SPSS to generate model summary and ON coefficients, interpret the regression output and determine whether height significantly predicts weight. Yeah, so first we can enter the given data um, to SPSS worksheet. So there are two variables. So first variable is height, the other one is weight. Uh, then we can enter the data, height for the first column, weight for the second column. Then so the first question is you have to draw a scatter plot. So graphs, legacy dialogues, scatter. Simple scatter we can draw. So x-axis. So we can take for the heights and the weight. So I will take height for the x-axis and weight for the y-axis. Mm, yeah. Then we can draw the scatter plot. So yeah, this is the scatter plot. You can see there is a positive relationship. It goes to this side. It means if that height is when height is increasing, so we can see that weight is also increasing here, right? So so we can see that positive trend there, but we can calculate that numerically. Therefore, here we can take the regression outcome there. So for that we can go analyze regression, simple linear regression linear, right? So we'll take the dependent variable as weight, then independent variable is height. Mm, yeah. So we need model summary and ON coefficients, right? Uh, so we can go plots, uh, options. Yeah. We can take that. I think we can take all these things. Yeah. So this is the output. Yeah, this we can see model summary and ON coefficients tables. And interpret the regression output, determine whether site is significantly predicts the weight. So we can write the first we have to write null hypothesis and the alternative hypothesis there, right? So we can write the null hypothesis. There is no significance relationship between height and weight. So then that should be the null hypothesis. There is no significant relationship between height and weight. So that is the null hypothesis. Then we can write the alternative hypothesis as there is a significance relationship between height and weight. So that is the alternative hypothesis. Then we can take these outputs. So you can see the R value is positive 8.6, 0.86, 0.86. So that is the R value, then coefficient. That is actually what you call correlation coefficient. Pearson correlation coefficient is 0.86. It means you can see there is a positive relationship there. Then we can find the R square value. R square value is 0.74. It means 74% of uh, the 74% of the dependent variable is explained by the independent variable. So that is, it means this model is you can use uh, for the regression analysis because there is a relationship, and also uh, the weight is predicted by the height because you can see the 74%, 0.74 R square value. It means 74% of the dependent variable is explained by the independent variable. Anyhow, that actually that the R square value is not a very good value. So last day we talk about that. So if it is a good model, this R square value should be greater than uh, uh, 0.80. Actually, it means it should be more than 80%. Anyhow, that this is quite closer to the 80%, that is 74. Then we can say tell that that is also a good model. Then when it's come to the ANOVA table, so you can see significant, you can see this significance value is 0.01. It means that is less than 0.05. It means the relationship is actually significant. And when it comes to the coefficient table, you can see here um, that so we can actually write this. Can write this. Yeah, we can write this. Uh, regression equation of the regression line, can write the equation of the regression line like this. Then here its dependent variable is weight, so we can write weight. Actually, this is why weight is equals to their intercept. So what is intercept there? Weight, intercept. Yeah, we can see there the intercept is right. Constant means intercept. No, the constant is negative 441.793. So negative uh, negative 441 point 793 plus then B, that is actually yeah, gradient. So it's equals 8.848 8.848 multiplied by height. Height means, so then that is actually weight equals to negative 441.793 plus 8.848 x. It means if you know the one of these values, if you know x, you can find y, and also if you know y, you can find x by using this regression line. So that is the first one. That is about the first one. Second one, second one, a chicken farm owner tests a new feed supplement to increase egg production. The dataset consists of 12 groups of 100 chickens, each receiving different supplement levels. So then you can see that data group, there are 12 groups. Then for feed supplement is mentioned there, and also number of eggs. So what we need to do is we need to find whether there is a relationship between this food supplement and the number of eggs they produce. So then first thing is you have to draw a scatter plot. You have to draw scatter plot. Yeah. Before that, we need to enter the data. We can go to the variable with group number, feed supplement and number of eggs. Then you can enter the data to the SPSS worksheet. So then we need, again, what we need was a scatter plot. Yeah, so we can draw the scatter plot, then graph, legacy dialogues. You can go for the scatter plot. Then number of eggs, that is dependent variable. Number of eggs, that is dependent. Feed supplement is independent variable. Yeah. So then he actually say, oh, this is actually very difficult, hard to predict which kind of relationship is there. So you can see here there is a positive relationship, but that should be very weak one. Yeah, because there is no trend lines we can see there as about the previous question, right? So anyhow, that we can use this analyze regression and linear regression. Dependent variable is number of eggs. Independent variable is food supply. Then we can take the output. So this is the output. So yeah, so the value of the correlation coefficient, that is 0.499. It means approximately that is equals to 0.5, right? So it means that there is no actually a very good relationship is there. And the other one is, so when it's come to the R square value, that is 0.249. So if we take this, the value R square value as percentage, that percentage is 24.9%. 24.9%. It means that the dependent variable is not very much explained by the independent variable if we use this method, right? So therefore, it's done here. We have to remember that. So definitely when you are uh, definitely when you are doing this kind of research, so you have to check whether what is the R square value they actually. So here in this case, actually you can't. Uh, then we can say in this case you can't say that that dependent variable is very much is explained by the independent variable. So actually yeah. So then when it's come to the ANOVA table also, you can see that 0.99, that is actually greater than 0.05. Then when it's come to the coefficients table, so you can see there actually here you had right the null hypothesis and the alternative hypothesis. Yeah, so then therefore we can write there is no significant relationship between food supplement and number of eggs produced. So that should be the null hypothesis, right? So then as same as you can write the alternative hypothesis, right? Alternative hypothesis. And so then when it's come to this one, right? Yes. Then we can write the equation. Right, here we can write the regression equation, right? Regression formula. Then we can write there. Mm, yes, we'll go, we'll write the equation there. So the dependent variable is actually number of x. Then we can write the regression equation number of x equals to right. So number of x equals to then coefficient constant value is 77.267 plus the footwear negative no 0.580 0.580 times food supplement. Right. So this is the actual regression equation of the regression line. So if you ey right, next one, the psychologist student examines how long effects of the alcohol on reaction time by measuring response time and the self-reported alcohol consumption per week. Yeah. So you have to draw the scatter plot, compute Pearson and Spearman correlation, interpret the correlation analysis. I think you can do that now. So I will go to this one multiple linear regression question, right? Question number 4. This is the question. The data set below examines how study habits, sleep duration, and exercise routines influence students' academic performance. It is designed for multiple linear regression analysis to explore predictive relationship among these variables. This dataset examines the relationship between students' study habits, sleep patterns, and exercise routines and their exam performance. The exam score is measured out of 100. Yeah. So these are the given data: study hours, sleep hours, exercise hours, and exam score. Right. First question is calculate mean, median, standard deviation for study hours, sleep hours, exercise hours, and exam score. Right. So we can enter the data like this. Okay. Study hours, sleep hours, exercise hours, and exam score. Right. Yeah, so then we can enter the data like that, like that. Then we can take the outputs as requested by this question. Then the first one, calculate mean, median, standard deviation. So analyze descriptive statistics. Um, right, so we need to take actually mean, median, standard deviation. Mean, median, standard deviation. Yeah, we need mean. We don't need minimum maximum. No, median is not there. Ne? Yeah, then we can take that one. So I think we have to go for explore. Analysis, descriptive statistics, then explore. Right, legacy dialogues. Explore. Yeah. Descriptive statistics, explore. Exploring descriptive statistics. Frequencies or type. Yeah. So these are the variable, all variable, right? These are the all variables. Yeah. Can mean, median, and standard deviation for everything. So let's go. We need mean, median, and standard deviation. These things. Okay. We can check the output of your output table. Yeah. So we can see the output actually. We need the mean, median, and standard deviation for study hours. It's mentioned like that. Sleep hours and exercise hours. So we can take from this, right? Second one, compute the correlation coefficient between study hours, exercise hours, and exam score. Perform multiple linear regression with exam score as an dependent variable and study hours, sleep hours, and exercise hours as independent variable. Right. First, calculate the correlation coefficient. Right. So we can go analysis, correlate, bivariate. Right. Then we can take this whole. Then we can calculate correlation coefficients. You can see that these are the correlation coefficients. So between study hours and sleep hours, there is a negative relationship. Yes, it means if that number of sleep hours are increased, the marks are decreased. Then again, that the other one is exercise hours and study hours. That is, there is a negative relationship. But if you consider that exam score and the study hours, when it's a positive relationship, it means the exam score that study hours, number of study hours are increases. It means that exam score will also increase. Yeah. That one, perform a multiple linear regression. Okay. So the dependent variable is study hours. The others are independent variables. Then we can go analyze regression linear. Dependent variable is exam score. All the others three are independent variables. Yeah, we can take the output. R square value is 0.63. Right, so we can write the equation of You can write multiple linear regression. Multiple linear regression. Perform dependent variable and independent variable there. So we can go we can go analyze analyze regression linear. We can take the output action. Then here we can write, so dependent variable is exam score. Therefore, we can write exam score equals to what? Our intercept, constant value, 53.043 plus coefficient on study hours. That is 3.117. 3.117 times what? Study hours. Plus, plus 2.121 times 2.121 times sleep hours plus 1.433 times exercise hours. So this is the regression. Actually, that is a regression equation now. So if we know these three things, study hours, sleep hours, and exercise hours, so we can predict the exam score by using this model. Right. Mhm. Write the regression equation. Okay, we'll write. So then we can R square value is model. So we get R square value is 0.63. It means 63% of the dependent variable is explained by the independent variable. That's okay. Then based on the regression model, predict the exam score. Yeah, so then here we can predict the exam score simply because we have these values. Then you have to actually substitute find this one. So exam score equals to 553.043 plus 1.117. Then study hours. Study hours is 6. So we have to substitute 6 there plus 2.121 times sleep hours 7 plus 1.433 times 3. So then this is actually the exam score. So you can uh, find using this regression formula. Right. Yeah, that is about right. So then we need to go with the next we can go for chi-square test. Last one. Chi-square test. Right. So we can enter the data here, right? So when we enter the data, right? When we are entering the data for the chi-square test, actually, so here we can see job type. So yeah, variable view, we can write job type here. It's mentioned supervisor, self-stacker, evaporate and cleaner. So it's and so here sex you can see one for male and two for female. Then we can enter this one. And, yeah, so then here supervisor like this we can say this, right? Then we can perform this chi-square test, right? We can go. Then first thing is data weight cases. So you need to weight this by count. Weight this by count. Okay. The second one is we can analyze descriptive statistics cross steps. Then rows. Yeah, rows job type, columns is count. Cells we need to take this expected one as well. Then here we can take this table. Yeah, okay. So then we can take the chi-square value as well. Yeah, so then here I didn't again analyze cross tabs, and we have to take the chi-square value as well. Okay, now we can find chi-square value here. Chi-square test. That is 0.005. It means significant. Significant. Right. So, Wind, any question? Make maybe the
No question, sir. Like,
Okay, right. Then we'll go to the today's part. That is session 5. So then actually then here we are talking about uh, principal component analysis, fact analysis actually. Then these rotation methods, then how to generate and interpret the factor scores for further analysis. Actually, so you can see this the introduction there, uh, right, about Pearson correlation, participation in the variance in factor analysis. So actually remember that. So sometimes, so if we consider some concept, right, these variables we can't measure directly. Samareva එක සැරේ mind බැහැ. So then anxiety. So we can't measure. That is a latent variable. අපි ඒවට කියනවා latent variables. Right? So then if we consider the measure, what we call motivation of the student, right? Motivation, that is a psychological concept. So motivation cannot be measured directly, right? So to have that students are motivated to do something, yeah, definitely we have to use some set of items actually belongs to a questionnaire. So then it's called these are the observed variables. But මේවා තමයි observed variables වෙන්නේ. latent variable. So then anxiety, that is a latent variables to find about the anxiety. So once that participant should be answer for these all eight items, right? So otherwise we can't tell about this anxiety, right? That's what I wanted to explain that. So then there are two types of variables. One is latent variable, and the other one is the observed variables. So the latent variable means that is actually we can't measure directly. So actually, therefore we have to use these items. Right. So then here there are eight items. So then for the SPSS anxiety, so in the question, yeah, I use these items. Then first one is I dream that Pearson is attacking me with correlation coefficients. Second one, I don't understand statistics. Third one, I have little experience with my computers. Fourth one, all computers hates me, and I have near been good at mathematics. Sixth one, my friends are better at statistics than me. Computers are useful only for playing games. I did badly at mathematics at school. Mm, yeah. So then next thing is so we can find the correlations. So whether it has correlations or not. So therefore we can go. Then we'll try to find. Right. Yeah, so we can calculate the analysis correlate by variate. So we can take the correlation there. Actually, yeah, we'll take not this one, no? Yeah, the job type. Yes, not that one. Right. So this is the data set. This is the data set. There are 2,571 entries in this data set. Right? Data set is this one. So then we can find first analyze correlation, correlate by variate. So then we can find the correlations between these variables, all variables, right? We can take the output like this, right? So then here you can see negative 0.99. Then in this one, 3.77, 3.18. Likewise, so you can find the correlations, and so you can see some are large, the positive correlations, some are past negative correlations, and so you need there are two flags there, flags So when compare these flags, to notice correlation is significant at 0.01 level. That means 99% confidence interval. So that is significant. And the other one is if it is 1 star, you can see there that is significant with 0.05 level. But anyhow, so you can observe there all the values are by the 99% confidence interval. That is significant. Right. So that is about the first one. Then we can go further. Uh, mm. Yeah. So then when we came to the factor analysis. Right. So then we have to know about these terminology first. So the common variance that shared among the set of items. So community, that is h squared, that the common variance that ranges between 0 and 1 actually. So that should be like a 0 and 1 අතර තියෙන මම පෙන්නන්න values පස්සේ. Then unique variance, the variance that is not common. So the common variance, the other one is unique variance. Specific variance. Variance is that specific to the particular item. The item for all components hurt me. Anxiety about the computer in addition to anxiety about SPSS. And so that is we call it specific variance. Then the other one is the error variance. That anything unexplained by the common or specific variances. For examples, mother got call from her baby sister that uh, her 2-year-old son ate her favorite lipstick. Right, so that is the error variance that is not relevant to these two. Yeah. So when it's come to this question from example, another example should have බැලුවොත්, right? So then actually, so this is the breakdown of our question. මේක තමයි practical problem එක, right? So when මේ වගේ එකක් තමයි අපිට practically හම්බ වෙන්නේ. So sometimes we can't measure that directly. සමහර ඔය psychological concept අපිට directly measure කරන්න බැහැ. එහෙම අවස්ථාවල අපිට use කරන්න වෙනවා these questionnaires. So there are 8 items to one latent variable, that is SPSS anxiety. So there are 8 observable variants, observed variables there. So we'll talk about the factor extraction and factor rotation actually. Uh, the model we can use actually are these two models actually principal component analysis. So exploratory factor analysis that is up to you. So you can do like a selected method actually. So sometimes we can use these estimation methods as well. So I am explaining that briefly actually. So we can use this principal axis factoring method or maximum likelihood that. A number of factors or components to extract. So sometimes we have to define how many factors we have to extract. Yeah, so sometimes we can automatically divide into that group. Right, then factor rotation. So we use orthogonal and oblique factor rotation. Right, then extracting factors. That is principal component analysis with two components and 8 components, and common factor analysis. That is principal axis factoring and maximum likelihood. So we'll talk about these three actually. So how we can use principal component analysis and how we can use the exploratory factor analysis for our principal axis factoring and maximum likelihood two factor model, right? So that is the thing we are focusing actually. So there are many things, right? ගොඩක් තියෙනවා අපි මේ එක විතරක් මේ factor analysis එකේදී focus කරමු. Right, principal component analysis. Principal component analysis. Goal to replicate the correlation matrix using the set of components that are fewer in number than the original set of items. Right, so there are 8 variables. So then, then if we need to, these 8 variables, සමහරවිට මේ තියෙනවා කිසි idea එකක් අපිට ගන්න බෑ. Right, so we can divide that into 2 components, right? So we are defining. අපි හිතනවා මේක components දෙකකට කඩා ගන්න කියලා. So for that we can use this principal component analysis, right? Principal component analysis. So then actually there are 2 ways actually based on the eigenvalues and eigenfactors we can categorize. Or the other one is, so we can decide so how many factors we need. So if we decide we need 2 factors, so they are finding that related factors and give us, so that is easy for us for this analysis process. So the eigenvalues, right? So total variance is explained by given principal component. So that is then eigenvectors, component loadings. So eigenvalues are, if eigenvalues are greater than 0, that is good actually, right? That means that should be positive values, right? Then negative eigenvalues is L condition. Eigenvalues are close to 0, that means multi-clonic or collinearity, right? So eigenvalues is greater, if eigenvalues are greater than 0, that is good actually. So there is component loadings, correlation of the items with principal components. Eigenvalues are some of the squared component loadings across all the items of the component. Yeah. So running a PCA with 8 components. Now we are starting the factor analysis. The first one is principal axis factoring. දැන් අපි factor analysis පටන් ගන්නවා. ඇයි අපි මේ factor analysis පටන් ගන්න කියලා අපි simply අපි define කරොත් මොකටද මේ factor analysis අපි use කරන්න කියලා. ඇත්තටම දැන් ඔයාලා questionnaires අපි හදනෝනේ. So sometimes we are preparing our question. Sometimes So our focus is to measure some latent variable. අපි try කරන්නේ මොකක් කර latent variable එකක් use කරන්න අපේ analysis වලට. But so sometimes the other instruments are not working as we expected. අපි හිතන විදිහටම අපේ instruments questionnaires එම හරියට function වෙන්නේ නැහැ. Then before conducting our research, first we have to check whether these components are working well or not, right? For that, so we can use this factor analysis actually. So to find whether this actually that is measured that we intend to measure those things, right? Therefore, that's why we are using this principal component analysis. And the other what do you call the fact analysis methods. Right. So we'll go with that example. Example that we can. Yeah. So this is actually our data set. So then we can go for the factor analysis. So analyze dimension reduction, factor analysis, factor analysis. Then yeah. So then method factor analysis. So we can use we can check this every variables. Then we can go for descriptives. Yeah. Then method. We can check. We have to. Then we have to check the method. So we'll check extraction. Okay. So rotation. Then options. No. Factor analysis. Extraction. Here you can see method should be principal component analysis. So then we can draw the script for that as well. The other one is that based on the eigenvalues. So eigenvalues are okay based on the eigenvalues කිව්වොත් එහෙම number of factors අපිට සමහර decide කරන්න බෑ eigenvalue එක අනුව automatically divide කරනවා. So the other thing is fixed number of factors. So we can decide how many factors to extract. The first one, so I will uh, type here 8. It means they are going to extract for eight factors. So then number of iterations of a convergence, so it's default 25, it's I increase for 100 there. Then continue, right? Yeah. Then we can take the output. Okay, this is the output. Look at the output. Right, this output is there. First, we can see this component matrix, this one, component matrix 0.659, 0.136. Yeah, this one. So we'll try to understand what will given by this table. මේ table එකේ මොනවද දෙන්නේ කියලා අපි පොඩ්ඩක් try කරලා බලමු. Right. Yeah, these are component loadings and these things there. So yeah, I will take another Excel file as well for yes. Then here, yeah. So then there we are. Yes. Yeah, eigenvalues are the sum of the squared component loadings of across all items of the component. So then sum of the then eigenvalues means that sum of the squared component loadings. So then these are the component loadings, actually correlations. We are available correlations. Okay. AK square capital බලන්න පුළුවන්, right? So then it means we can write square. 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 Square means power, ne? Power. Power. Make a power 2. Second power. Right. Right. And then we can take power 2 of this whole. Power 2.
So
Yeah.
can you
Then we
share
can.
data set?
This Excel file.
Yes, yes, sorry.
Alright, data set is correlations. Okay, I will share it. Mm. Ah, you can't see that, no?
Yes, I
Sorry.
mean on the screen, yes.
Yeah, now it's okay. Right. These are the correlations. Then we can, yeah, I will do it again then. Yeah, so then these are the correlations. So then eigenvalues we are going to find. So then actually that is square of these correlations. Uh, First we can find, then we can use square power, then power 2. Then squares we can take, right? So then these are the squares. Um, yeah, so eigenvalues are the sum of the squared component loadings. So these are the component loadings, it means the correlations. So then we can take the squared, then sum of the squared, then we can uh, take the sum of this, that is 3.057, 3.057. If we take sum of that, wait, right, then we can take the sum of this. මේක එකතු කරනවා. Sum making me. So then 3.057 here, the 3.057, 1.067. Likewise, we can take the sum of the square. So sum of the squared loadings of the column. So we can take as the eigenvalues. So මේවා තමයි eigenvalues විදියට එන්නේ. Right? Uh, then sum of the loadings across compound communality. Right? Then we can find the communality. Communality is in that side. It is sum of the squared loading across the compound, right? Sum of the squared loadings across the compounds. Yeah, so the meaning is that yes, right. So then that is what we can take from then this one. Then yeah, then we go to the output. Total variance explained. This one. Total variance explained. This table, right? So then these are the eigenvalues. Then අපි මේ ගත්ත eigenvalues ටික principal component analysis එකෙන් ඒ table එකේ මෙතනට අවිල්ලා තියෙනවා ඒ ටික මේ 0.357 අර Excel එකෙන් අපි හෙව්වේ ඒ ටිකම තමයි. Right? Right. This one. Right? And so yeah. So these are the initial values. Then principal component analysis we use, that is the extraction method. Right? So yeah, extraction, sum of the squared loadings, the same things is there because we didn't use the some rotation methods, monoth rotation methods පාවිච්චි කරපු නැති හින්දා ඒකේ ඒ විදිහටම තියෙනවා. Right? So while left column is same as the right. So because extraction sum squared is equals to eigenvalues. මෙතන අපි rotation method එකක් පාවිච්චි කරපු නැති හින්දා ඒක eigenvalues වලටම සමාන වෙලා තියෙනවා. So අපි ඊළඟ examples වලදී we are using some of the rotation methods. Then these two are not actually exactly same method. ඒ දෙක එකට එන්නේ නැහැ. Right? Then we can draw a scree plot. This is the scree plot. මේ scree plot එක පුළුවන්. එතකොට why eigenvalues are greater than 1 in criteria. So here, we discussed that. So eigenvalues uh, greater than should be. Then you can see that of elbow එකක් වගේ මෙතන තියෙනවා, right? So look at the elbow here. Recall eigenvalues represent the total variance explained by the component. Since the community is one, the principal component analysis for a single item, if the eigenvalues is greater than 1, it's explained community of more than 1. For the මෙන්න eigenvalues you can see there. So based on the eigenvalues, sometimes you can apply පුළුවන් groups වලට වෙන් කරගන්න. එතකොට right මේ අපි 8කටනේ ගත්තේ. අපි ඔක දෙකකට කරලා බලමු. right දැන් මේ eigenvalues වලින් අපි 8කට හදාගන්න කිව්වේ මේක මෙතනින් මේ 8කට කඩාගත්තේ මේ components 8කට කඩාගත්තේ අපි. right so then same thing I am going to do then again analysis dimension reduction factor. Here we are going to the extraction. So fixed number of factors 8 take them on 2 volt අඩු කරන්න. right 8 I will change to 2 there. right yeah so all the others are same. Okay then continue. Okay yeah again you can see this yeah commonalities. දැන් මෙතන දැන් බලන්න difference එක. දැන් ඉස්සෙල්ලා when it goes to the previous one yeah this one. So total variance explained is here මෙතන components 8යි තිබ්බේ. ඊට පස්සේ extraction method එකෙමුත් අපි components 8ම අරන් තිබ්බා. right? මම මේ කියන එක පැහැදිලිද කියලා බලන්න. මේ components 8 කියලා කියන අපි questionnaire එකේ දීපු questions 8. right? questionnaire එකේ දීපු questions 8. මම ඒකල මම යාගෙන් අපි group කරලා variable වලට මේ ඉල්ලන්නේ factor analysis වලින්. right? ඒ කියන්නේ අපි වෙන වෙන variables හදාගන්න. right? ඒතොර මේ variables වලට අදාළ ඒවා තමයි අපි මේ try කරන්නේ factor analysis එකෙන් හොයාගන්න. ඒතර මෙතන මම 8ක් මිල්ලපු හින්දා ඒක ඒ විදිහටම ආවා. එතකොට අර අපේ questionnaire එකේ තියෙන items එකතු වෙන එකක් උනේ නැහැ. ඇයි ඒ questionnaire එකේ items 8ක් තියෙන මම 8ක්ම ඉල්ලුවා. right now when it's come to the second case ඊළඟ case එකේ අපහම උනේ right questionnaire එකේ මේ තියෙන්නේ අර වේ values ටික ඒකම eigen values මෙතන වෙනස් නැහැ principal component analysis initial eigen values තියෙනවා මෙතන 8ක් මම ඒක දෙකක් කරලා අරපෙන්නේ මම දෙකකට හදලා ඉල්ලක දැන් 8 මේ තියෙන item 8 variables දෙකකට මම වෙනස් කරගෙන තියෙනවා right that is what happened in there අපි මේ dimension reduction කියන්නේ ඒක අපි මේ තියෙන එක components එක reduct කරගන්නවා එතකොට ඒකෙන් අපිට ගන්න ලේසි analysis එකට then no notice only two eigen values මේක එතකොට දෙකකට දැන් වෙනස් කරගන්න right by using this principal component analysis. Yeah, then you can see that communities as well. Communities. Yeah, then these extraction methods are there 0.537. Which means what is the meaning of this is 0.53 553 can 45% 3% of the variance of item 1 item 1 is explained by this component 1 එක තමයි ඔය කියන්නේ. right so that is the meaning of that. but මෙන්න දැන් මම දෙකකට අඩු කරගෙන තියෙනවා අපි further analysis වලට යන්න. yeah so I will show from there මම මේ output එකෙන් පෙන්නන්න. right so then here you can see yeah මෙන්න මේකේ බලා ගන්න පුළුවන් screen plot එක මේකේ තියෙන මෙන්න yeah yes component matrix again. So there are two. මේක දෙකක් තියෙනවා. right so extraction method is principal component analysis two components extract. so මේ අපේ අර තිබ්බ ප්‍රශ්න 8 components දෙකකට අපි බෙදාගෙන තියෙනවා. right so using this principal component analysis so ඕක තමයි අපි ඔය අපි කරන්නේ validity බලනවා කියන්නේ ඕකයි because when once we created a questionnaire first we need to check the validity and the reliability. So to check the validity so we can use confirmatory factor analysis and exploratory factor analysis. Unfortunately the available what you call analysis, fact analysis method is exploratory fact analysis in SPSS. But if you use this IBM XPSS AMOS, so you can do confirmatory fact analysis as well, but it is not included in the SPSS statistics software, right? So, right, we can go further now. Without right. So then we can go for the extracting factors. අපි දැන් factors product extract කරගමු. Common factor analysis වලින්. ඒකෙන් අපි factors ටිකක් අපි extract කරගන්න යන්නේ. Right, factor analysis. Exploratory factor analysis actually අපි කතා කරන්නේ. Goal is ඔන්න බලන්න. Goal also to reduce the dimensionality, but assume that total variance can be divided into common and unique variance. Make more sense to define construct with measurements error. So then මේ තියෙන මෙන්න මේ ෆැක්ටර්ස් ටික නැත්නම් මේ අයිටම්ස් ටික අපි එකතු කරලා ඒක අපි හිතමුකෝ මේ එකතු වෙන හැටි තමයි අපි ඇත්තටම බලන්නේ. අපි හිතමුකෝ item 1 එක item 3 එක item 4 එක එකතු වෙලා තව variable එකක් හැදෙනවා. right? අන්න එහෙම variables හදාගෙන තමයි අපි මේ try කරන්නේ මේ fact analysis වලින්. Through fact analysis we are trying to find some construct actually, right? To do our analysis purpose. So it means we are going to reduce our question here. අපි හිතමු items 50ක් තියෙනවා නම් ඒ 50 අපි අඩු කරගන්න යනවා for the analysis purpose. Yeah. So we'll go to now principal axis factoring is the principal component analysis වලින්, right? Yeah. So then we are not changing anything. So we are changing only the extraction method now. Method of extraction we are going to change for principal component analysis. Make note the what eigenvalues will come back once hours later. SPSS does not change its menu to reflect change in your analysis. You have to know this one. Right. We'll take the outputs of your output column. So then what we can do is analysis, dimension reduction, factor analysis. All the things are same. Then extraction method, I'm going to change. Principal component analysis for the principal axis factory. But then we're going principal component analysis to principal axis factory. Then okay. Then again we can see these outputs. Yeah. Then we here yeah, outputs. Right. Commonality is there 0.293. Its extraction method it's changed to 0.437. Right. Some of the communities we can take as 3.01 there. Right. Initial communities are squared multiple of correlation coefficients controlling for the other items in your model. අපි හදාගත්ත මතක initial coefficients. අර correlation එකේ අපි ගත්ත square ගැන අපි ගත්තේ. What is the initial community for the principal component analysis? Right? Yeah. So the total variance explained, second output, total variance explained. So we can here also extract for the two factors. The American factors attend they can reduce right? Uh, Unlike principal component analysis model, the sum of the initial eigenvalues do not equal to the sum of the squared loadings. Then again make a equal when in a make it. Right? So sum of the eigenvalues equals to 4.124. Right? The reason is because the eigenvalues for principal component analysis is not factor analysis. SPSS idiosyncrasies. Right? So the square loading is factor 1. So there are two factors actually. So then what we do that we reduce to two factors using this principal principal axis factoring method. Right, then two factors. So you can see that sum of the square loadings in first factor is equals to 2.510. And for the second factor, that is 0.499, right? 0.45. And then sum of the communities may the case sum 3.01. 3.01. Right? Is the sum of the earlier. Okay. Yeah, then we can see if we take the sum of these communities, that is 3.01. මේ ඔක්කොගෙම sum එක. ඒ කියන්නේ මේ තියෙන initial values ටික. අර තිබ්බ 8ක් තියෙනකොට තිබ්බ values ටික මේ තියෙන. ඒ ටිකේ extract sum of the communities ගත්තොත් මේ ටික ඔක්කොම එකතු කරපුවම එන්නේ 3.01. ඒ කියන්නේ මේ factors 8ම then මේක reduce කරලා තියෙන factors දෙකකට. But if we take the sum of the communities, it's remain as same 3.01. 3.01. So some of the communities does not change, so our model is reduced to two factors only. Right. The other one is sometimes that we can. I told you that. So අපි factors ගන්න දැන් අපි decide කරලා නෙවෙයි කියන්නේ. But sometimes we can reduce this our අපිට reduce කරන්න පුළුවන් අපේ items ගන්න අපි දාන්නේ නැහැ. Right. We are not entering the number of items. So based on the eigenvalues, we will give the freedom to the SPSS to separate the items by using this the eigenvalues they have බලලා when කරන්න කියලා අපි chance අවස්ථාවක් දෙනවා සමහර වෙලාවට, because if we don't have any idea about how that variables are related with the others, so the best thing is, so we have to give the permission to SPSS to group them by using some criteria. Yeah. So based on the eigenvalues, our fixed number of factors. So based on the eigenvalues, so we can use that eigenvalues greater than 1. We just try analysis, dimension reduction, fact analysis. Okay, extraction. Yeah, based on the eigenvalues greater than 1. Eigenvalues greater than 1 right? Yes, okay. Yes, we can see again. එහෙම කරත් මේ factors දෙකට එයා වෙන් කරගත්තා. But this ඉස්සලා දීපු factors දෙක නෙමෙයි, but it's extracted into the two factors again. එහෙම දුන්නත් මෙයා eigenvalues දෙක බලලා factors දෙකට තමයි වෙන් කරගත්තේ. Right? Yeah. So then this is factor 1 and this is factor 2. Extraction method is principal access factoring. After 79 iterations, they selected these two factors actually. Factors දෙකට වෙන් කරගත්ත මෙන්න මේ iterations 79ක් ඉවර වෙලා. Right? Yeah. This is the scree plot. When a scree plot එක එකට වැඩි ඒවා මේ තියෙන eigenvalues. මේ තියෙන එකට අඩු ඒවා. When you look at the scree plot of in SPSS, you are making conscious decision to use principal component analysis solution as a proxy for your EFA. Right. We'll go for the part diagram. මෙන්න මේ වැඩේ තමයි අපි කරගන්න try කරන්නේ. Right? මේ තියෙන latent variables. So අපි මේ relationships තමයි බලන්නේ. දැන් මම මේකේ බලන්න. Right? මේ දැන් ඔය factor analysis වලින් factors දෙකකට අපි වෙන් කරගත්තා. One factor is SPSS anxiety. The other one is blue one. Blue one is SPSS anxiety. The green one is tech anxiety. So then to check the SPSS anxiety, so we need to combine this item 1, item 3, item 4. So by using that, so we can find the SPSS anxiety. So to find the tech anxiety, so we have to take the item 3, item 5, item 6, and item 7. Right? I think you have the idea about why we are using this factor analysis. ඇයි අපි මේ factor analysis ගන්න idea එක දැන් නම් ඇවිත් ඇති කියලා මට හිතෙනවා, because we need to create some variables which cannot be directly observed. Directly observe කරන්න බැරි ඒවා. Right? So by using this factor analysis, we can categorize them into one variable. Right. So that is, I think, our last output is there. Right? Which items has total variance explained by two factors. එතකොට මෙතන factors දෙකක් අපිට අවිලා තියෙනවා. What is that? 2.511. A caution when interpreting unrotated loadings, most total variance explained by the first factor. Yeah, okay. Only selected loadings shown. So then අපිට path diagram එකක් අදින්න පුළුවන්. මේකට අපි කියන path diagram කියලා. So we can draw path diagrams. So by mentioning this, what do you call this relationship? So you can see here SPSS anxiety. So then item 1, it has 0.59, right? So then for the item 2, it has negative 0.23. So, and to a third one, negative 0.557. And when it's come to the fourth one, right, it is 0.19, negative 19. Likewise, right? So they didn't with decaying aragatic, right? Likewise, we can find. Okay. The relationship between three tables. There are these three tables. So we made tables to a relationship. Right. First one, factor or component matrix. First matrix. And so squared of each elements. Right. Factor එකෙන් ගත්තම එක squared එක ගත්තම squared loadings අපිට ගන්න පුළුවන්. If we add these squared loadings, so we can take that මොකද්ද අපිට ගන්න පුළුවන් eigenvalues. But squared loadings can be divided into two eigenvalues for principal component analysis, or the sum of the squared loadings for principal axis factoring. And sum of across all these components මේ ඔක්කොගෙම sum එක අපිට ගන්න පුළුවන් communities විදිහට. So we can add this whole, right? Sum down these components, sum down these components, so we can take the total variance. Total variance. Okay. Right. So that is what මේ මේ ටික ඔක්කොම එකතු කරාම තමයි 3.01 ආවේ by from exploratory fact analysis. Right. අපි යන් for rotation method එකට estimate එකට, right? That now we can use maximum likelihood fact method. වෙනස් කරන්නේ method එක විතරයි. Right? So we'll go to their analysis, dimension reduction, fact analysis. Extraction method එක තමයි වෙනස් කරනවා මොකේද? Maximum likelihood extraction method to take the output එකත් අපි right? Yes, then our chi-square value, now we get chi-square value එකක් දෙනවා. Where is chi-square value is 198.617, 198.617 of degrees of freedom, right? And it's less than 0.05, it means that is significant value. A significant chi-square means you reject the current hypothesized model, right? Significant chi-square value එකක් තිබුණත් අපිට මේ hypothesized model එක reject කරන්න පුළුවන්. Chi-square table. Chi-square and degrees of freedom gets down. Number of factors. Yeah, so then when it's come to that iterations, right, you cannot request factors, right? To make a 8-factor model එකකට එහා තමයි අරගෙන තියෙන්නේ, right? Comparing EFA with principal component analysis. පොඩි comparison එකක් අපි යමු. අපි පොඩි rotation method එකකුත් අපි බලමු. right? rotation එකක්. so මේක ඇත්තටම practice කරලා බලන්න වෙනවා. just සමහර විට කිව්වට තේරෙන්නේ නැතිව just අපි ආපහු වීඩියෝ එක බලන ගමන් හිමීට බලන්න. මොකද මේකේ content එක චුට්ටක් වැඩි හින්දා සමහර විට ඒක පොඩි පැටලිල්ලක් එන්නත් ඉඩ තියෙන හින්දා. right, අපි පොඩි rotation method එකකට යන් මෙන්න බලන්න. so that what we need to do. මේක තමයි අපේ අත්‍තරම ගන්න idea එක. දැන් අපේ අර තියෙනවනේ අපේ items 8 තියෙනවා. මෙන්න එක fact එකකට ගිහිල්ලා මෙන්න factor 2 වලට තව එකක් ගිහිල්ලා factor 3 වලට තව එකක් ගිහිල්ලා. එතකොට මේ 8 දැන් අපි factors තුනකට කඩන් තියෙන meaningful factors. ඒත් මේවට අපිට නමක් දෙන්නත් පුළුවන්. right? ඒතර මේවා තමයි ඊට පස්සේ අපි මේ දැන් මේ තියෙන ඊට පස්සේ මෙතනින් එහාට මේ items 8 අපිට items 3ක් විදිහට පාවිච්චි කරන්න පුළුවන්. මේ තුනට අපිට දාගන්න පුළුවන් එක නමක්. so එතකොට ඒක variable එකක්. මේ තුනට දාගන්න පුළුවන් තව නමක්. ඒතර ඒක තේරුමක් ඇතුව අපිට නිකන් එහෙම මම 1.5 එකතු කරනවා කියලා එහෙම එකතු කරන්න බෑ. right? so I think you got the idea. right? right. so running two factor solutions. අපි බලමු පොඩි rotated method එකක් මේ varimax rotation එක පාවිච්චි කරපු two factor model එකකට යන්නේ. right. same thing analysis, dimension reduction, factor analysis. දැන් අපි rotation method එක මෙතනින් ගන්නවා. මෙයා use කරලා තියෙන varimax rotation method. right, loading plots and number of iterations 100. okay, continue. I will output. yeah, then these are the two factors. factor transformation matrix. factors දෙකකට අපි වෙන් කරගත්තා. one is method එක use කරලා තියෙන principal maximum likelihood නෙමෙයි principal axis factoring. yes, we'll take that output analysis. dimension reduction factor method we have to check principal axis factoring. Principal axis factoring rotation. yes, okay. okay, now we'll see there. This is factor transformation matrix 0.7573 and 0.635. In this table you can see here. Actually factor transformation matrix factor matrix එක තියෙනවා. rotated factor matrix එකට අපි ගන්නෙ by using this factor transformation matrix. මේ තියෙන factor transformation matrix එක. the factor is that transformation matrix turns regular factor into the rotated factor matrix. එතන අපි මේක rotate කරලා අපිට ඕන විදිහට හදාගන්න එක තමයි කරන්නේ. right? so තියෙන්නේ මේක rotate කරලා ගන්න. unrotated axis එක තියෙනවා. this is rotated axis. so we can rotate this. okay, rotated factor matrix. අපි යනවා unrotated solution එකට. rotated solution. okay, factor matrix. factor matrix is this one and this is the rotated matrix. then මෙන්න මේක rotate කරලා තියෙන method. commonalities බලන්න same. commonalities ටික වෙනස් වෙලා නැහැ. those are same. right, only thing is these values factors changed. maximize sum of the variance of the squared loadings. yeah, then make based on this may rotation එකෙන් අපේ factors දෙකකට වෙන් කරගෙන තියෙනවා. right, මේ දින unrotated solution එක. so this is rotated solution. then higher absolute loadings we can take from this what do you call this by this rotation. so then you can see two. yeah, so then you can total variance explain. so you can see that there are two factors there. extraction sum that is 3.01. මතක කරලා බලන්න මේ 3.01 ඒ විදිහම rotate කරලා තියාගෙන තියෙනවා. right, even though the distributions of the variance is different, total sum of the square loadings is same. square loadings same. right, so just I wanted to explain that. so to take the idea body idea එකක් ගන්න මේ කරන්න කියලා තමයි මම කිව්වේ ඇත්ත. right, මම හිතන්නේ actively participate වෙන්නේ මෙයා විතරයි. මේ ඔයාලගේ batch එකේ තමයි එහෙම අඩු වුනේ. අනිත් අය ගැන කීප දෙනෙක් හරි හිටියේ අපිට කතා බහ කරන්න. හරි, දැන් මෙයා ඔයාලගේ ඔක්කොම මේ batch එකේ ඉන්න අය මොනවාද recordings focus කරලා තමයි සම්බන්ධ වෙලා තිබුණේ. Been there any questions to ask? Been there එකකින් විතරයි හින්දා මට අහන්න තියෙන්නේ. I don't know how make a complex another.
ඔව් ටිකක් කොම්ප්ලෙක්ස් ඒ වුණාට මේ වීඩියෝ එක මම නැවත නැවත බලන්නම් එතකොට මේ
හරි ඒක එහෙම කරන්න වින්දයා ඊට පස්සේ if you have any problem so you can contact after this course as well doesn't matter right